Hi everyone, this is Mr. Zikri. In this episode, we are going to study about Pascal principle. Pascal principle said that a pressure applied to a fluid, liquids or gases, is transmitted in every direction. Unlike the principle in solid pressure, a pressure from a hammer will be transferred to the nail, and the pressure from the nail will be transferred as same direction as hammer to the nail. While here, in gases, a balloon full of air is being pressed downward. The pressure will be spread out equally to all directions. Here, we have a bottle of water, and if we press this middle of this bottle, the pressure will be spread equally to all area, to all direction, with the same amount of value. So here, for example, if we have small area here, we will have small force acting on this area, while in another part, if we have bigger area, it will have bigger force, but the pressure will be the same. So look at this number. If we have 2/1, it will be the same with 40/20, but the value of it is 2. So that means, for example, the pressure are 2 in every direction, so the force applied depending on the area, because we know the pressure equal to force over area. So if the area is small, the force given also small, but if area is bigger, the force also bigger, but the value of the pressure will be the same. It is used in braking system. So here, the brake pedal, if you apply small force here to a small area of piston, you will create pressure, and that pressure is being transferred through the oil. And here, the pressure, when it pushes this larger piston, it will create larger force. Thus, it will stop this disc from rotating. Another example of Pascal principle is in hydraulic lift. Here we have U2 with left tube area is smaller than right tube area here. So small area will need only small force, and it will create pressure that is transmitted to all direction with the same value. So larger area mean it will create more force. The principle is simple. There is a transfer of pressure on this liquid. So the pressure on the left tube equal to the pressure on the right tube. As you know that the pressure itself is the force over area, so F1 over A1 equal to F2 over A2. So given the quantity here, the downward force is 500 Newton. Area of left tube is 1 meter squared. Area on right tube is 20 meter squared. What is the force on right tube? As you can see here, the weight of the car is actually force that is being produced on the right tube. We can use Pascal principle. F1 A1 equal to F2 A2. So F1 500 over 1 equal to unknown over 20. So F2 equal to 500 times 20. It's 10,000 Newton. So this weight of the car is 10,000 Newton, or if we convert it into mass, it becomes 1,000 kilogram or 1 ton. Here is the last slide that we are going to study. We want to know what is the height of this liquid. What is the height H in centimeter when the system is at rest? The system is at rest means that the system is in equilibrium state. There is no moving. There is no extra force. So as we can see here, I draw a red line and I draw 2 dots here. Both have the same amount of force. So pressure at A equal to pressure at B. Pressure at A is caused by the mass of the piston or the weight of the piston and the liquid pressure. So let's say P1 added by pH equal to here at B there is a pressure because of the weight of the piston also. Let's say this is P2. This is F1 A1 added by HDG equal to F2 A2. So the force is actually the weight of the piston, so mass times gravity, mass 1 times gravity over A1 added by HDG equal to mass 2 times G over A2. Now in every part here there is G, gravity. Actually we can cancel them. So there is M1 100 gram over A1 is 10 centimeter squared. H is unknown and density given 1, mass 2 2000 over 100. So here is 10 added by H equal to 20. So the height is actually 20 minus 10, so the height is 10 centimeter. Okay guys, that's all for today. I hope you enjoyed this video. I hope you learned something from this. Do not forget to write it down all the materials from this video. See you next time. Bye bye.